So the volume of this cube is 8. What does that mean? It means that to create this cube, right, they used, let me see if I can draw it. It's a 2 by 2. If you look at a cube this way, so if you look, there are 2 layers. The first layer here and the top layer. At the bottom, let's see if I can draw it. Right? If you look at this, and if you were to count the number of cubes that were used to build the bottom layer, you would have 1, and I'll shade, this is 1, 2, 3 here, and that 4. So there are 4 cubes used for the bottom layer, and because the top layer is exactly the same, there'd be another cube, which makes the volume of this particular cube 8, in this case 8 inches squared. But what are the side measurements? Well, the side measurements measure 1 inch, 2 inches, and this measures 1 inch, another inch. And remember, there's another layer on top that I didn't draw. Right, there's another layer on top. So with the other layer, you have 4 cubes on the top and a total of 8. But in a cube, or a perfect cube in this case, right? A perfect cube that whose volume is 8, what are the side measurements? Well, the sides would be 2, 2, and 2. So that's our answer. Right? In a cube, so imagine this cube, and there are 512 of these that were used in here, right? And if it's a cube, we know that this side, and this side measures the same. So, knowing that they measure the same, what same number multiplied by itself 3 times gives you 512? Well, you can just put that in your calculator, and let's see if I can do it. 512 cubic root would be 8. And again, you can take this in your calculator and see if 8 times 8 times 8, 8 times 8 is 64, times that 8 would actually give you 512. So, a big cube where 512 of these were used to make that, what are the side measurements? The side measurements, this measures 8, the height measures 8, and the width measures 8. Okay. You have another one, and this one's another perfect cube, right? A perfect cube is a cube where all 3 side lengths measure the same, and in this case, what 3 numbers were used, right? It would be a 4, a 4, and a 4. So the height is 4, the length measures 4, and the width measures 4, right? So we're talking about cubes, and again, imagine these cubes that measure 1 inch on all sides. How many of these little cubes were put together to make that big one? Okay, in this case, so there were 64, and because there were 64, each of the sides measure 4, 4, and 4. For the following problems, you can just take the cube root. Again, if you take the cube root, what's the cube root of 729? It's 9, because 9 times 9 times 9 is 729. The cube root of negative 25, so remember the cube root of a negative number, you can already say it's a negative. In this case, it's going to be negative 5. The cube root of negative 1,000 would be negative 10, because 10 times 10 times 10 is 1,000. The cube root of 1,728 would be 12, because 12 times 12 times 12 is that. The cube root of negative 1 over 512 would be negative 1 over something, because at the top 1 times 1 times 1 is 1, but what is the cube root of 512, which would be 8. Because 8 times 8 times 8. So in this case, negative 1/8 times negative 1/8 times negative 1/8 equals negative 1 over 512. And the last one, and again, what three fractions multiplied by themselves equals 343 over 64. Well, 64 I know, it's just 4, because 4 times 4, so if I can erase that with that, 4 times 4 times 4 gives me the 64, so I know the bottom is 4, but 343, what's the cube root of 343? Which would be 7. So if you took 7/4 times 7/4 times 7/4 and multiplied, it would give you 343 over 64. Okay. So very similar, right, to square roots. Not much of a difference. Now, solving the equations. When you solve the equation, you have to go through a process, right? Because we want h by itself, and we don't want the h with exponent of 3. We just want h with the exponent of 1. So how do I get that to look like this? Well, I got to get rid of that 3. And to get rid of the 3, we're going to we're going to take the cubic root of that side, and we're going to take the cube root of that side. Now remember, this 3 and this 3 will cancel out, and we finally have h all alone by itself. And on the other side, what number multiplied by itself 3 times gives you 1,331? It'd be 11. Same thing here, and again, we're just going through the process, right? How do I make k to the third power become just k? We know the answer is going to be, well, we'll get to there. So first, let me show you how we're going to get rid of that exponent of 3. We're going to take the cube root of that. And by taking the cube root, this guy and this guy will go away and simplify, and I'm going to be left with k. On the other left side, I'm going to take the cube root of negative 125. So what number times itself 3 times will give me negative 25? First of all, we know it's going to be negative, and it's going to be 5. Negative 5 times negative 5 times negative 5 is negative 125. Approximate the cube roots. So we're going to do the double number line method that we do in class. So let's list. You got to use that list of perfect cubes that we wrote in class. So 200 is between the cube root of 125 and the cube root of 260. Right? The cube root of 125 is just 5. That's just another way of saying 5. And the cube root of 216 is just 6. Where's 200? 200, let's see, it's about 125. About here. The cube root. 125, 35, 45, 55, 65, 75, 35. Yeah, it's about there. So drop a line. What does this spot look like in my number line at the bottom? I don't know. 5.7, 5.8. Just out of curiosity, let me put the cube root of 200 in my calculator, and we get, calculator says it's 5.84. So we're pretty close. Right, so approximately 5.8. Next one, what's the cube root of 1,750? Well, let's figure out what's in between. Oh, this one might be a little, let's see, 15. Give me a second. So it would be between 1,750 and 728, and the next perfect cube after that would be 2,197, and this is just fancy way of saying 12. So the cube root of 1,728 is 12, and the cube root of 2,197 is 13. So where is 1,750? 1,750, let's see, 700, 800, 700, 800, 900, 2,000, 2,000, around here. Let me change colors. So approximate That's where one cube root of 1,750. Let's drop a line. Does that look like 12.1? I'm gonna go for 12.1. So it's about 12.1. Let's see how far or close we are. Take the cube root of 1,750 in your calculator, and in your calculator it says 12.05, etc. So we're not that far off at all. We're pretty close. Okay. What else? Is that it? No. The number 125 is not a perfect square. Is that true? Well, that is true. 125 is not a perfect square. Remember your list of perfect squares? 1, 4, 9. That's different than perfect cube. Okay? 16, 25, 36, 49. I've just got to go 64, 81, 100, 121, 144. So 125, it's not a perfect square. That's absolutely true. The cube root of a perfect cube is an integer of a perfect cube. So again, go through your list of perfect cubes today. 1, 8, because that's 2 times 2 times 2. 3 times 3 times 3, 3 times 27, 64, 125. Right? If you took the cube root of all these, think about that, of a perfect cube, right? If you took the cube root of these, cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5. Even if it was negative, it could have been negative 1, negative 2, negative 3, negative 4, negative 5. So it's always an integer. Remember, these numbers belong to the integer family. So is that true? Yes, but they have to be a perfect cube, which is what that says. So that's also true. Taking the cube root and cubing a root number are the opposites. Yes, that is true. Right? So if you take a number 5 to the third power, for example, that gives you 125. And if you took the cube root of 125, you took the cube root of 125, would that return to 5? Yes. Okay. So they're opposites. They undo each other. The symbol for cube root and square root is the same. I don't know if they mean this. Right? Radical. Because the square root, there's a 2 here. And cube root, there's a 3. So I'm not too sure about this one. I'm going to say false. You can use cube roots to find the edge of a length of a cube given just the volume, because all edges length in the cube are the same. Yeah, that's absolutely true. So remember the first exercise we did. Here's a cube, right? So imagine this cube over here, right? And I tell you that the volume is 64. What does that mean, that the volume is 64? Well, it means that there were 64 of these guys here used to make that cube, right? So if it's a perfect cube, right? Well, actually it doesn't say anything about perfect cube, but if that's the volume, if I know the volume, can you find out what the height and the length and the width is on the cube? Yes, you can. Well, because they're all the same numbers. In this case, it would be 4, 4, 4. This one is true. Draw a circle around the perfect cubes and write the cube root. Okay, that's a perfect cube. I made a list, so you know. So that's 3. What else? 512 is a perfect cube, and that equals to 1, 2, 3, 4, 5, 6, 7, 8. That's 8. That's a perfect cube, right? It's 4 times 4 times 4. 729 is also a perfect cube, and that is 9. Okay, now those are perfect cubes. The rest are not perfect cubes. For example, 144, there is no number that multiplies by itself 3 times. That gives you 140. But it's a perfect square, right? Because 12 times 12 is 12, so the square root of 144 will be 12. But we're talking about cubes, so that's not it. Not. Romney's most popular wooden box has a volume of 512. What is the cube root of 512? And again, is there a number times itself 3 times that gives you 512? Yes, there is. It's 8, right? Because 8 times 8 times 8 is 512. Is 512 a perfect cube? Yes, meaning this, and this are exactly the same. So the answer is yes. Ronnie's largest wooden box has a volume of 1,000. Is 1,000 a perfect cube? Well, what's the cube root of 1,000? Which is 10. Which is 10 times 10 times 10. Is 1,000 a perfect cube? Yes, it is. Right? Ronnie's least popular box has a volume 650. Now, if you put in 650 in your calculator, right? Cubic 650. If you look at our list, is not a perfect cube. There's no 3 numbers that multiply by themselves exactly give you 650. So that's going to be a decimal, and it's going to be, let's round this to 8.66. Is 650 a perfect cube? No, it's not. I mean, it's approximate, right? So think about it. Let's try 8.66 times 8.66 times 8.66. Will we get 650 exactly? Well, let's give it a try. Times 8.66 times 8.66. So I get 649.46. Close to 650. Is it 50? 650? No, but we get close. So the more decimal numbers that we could have used, the closer it would have been to 650, but not 650. So not a perfect cube. 4, let's see, 139. Is 139 a perfect cube? I mean, we already know that's not because we have a list, but 139, take take the cube root, and if you look in your calculator, it's going to be approximately 5.1801. And I'm going to go a few decimal places, 0. The answer is no. And again, let's take, again, your calculator has more decimals than that, but let's take that. Let me take that. I took more decimal places in the previous problem. And let me multiply that 3 times. 5.1801 times 5.1801. So let me do that. 5.180101 times 5.180101 times 5.180101, and it's going to give me 138.9999623757246 ... Notice that we are super close to 139, but are we at 139? No, so this is not a perfect cube. Okay. Is that it? Wow, really? All right, that was your check understanding. Okay.